from this equation. Sum of moment around A is equal to I around A times alpha. Alright? So what is the sum of moment around A? It's only the moment of the weight, because in fact the forces, the reactions are passing through A. And what is IA? If I want to find IA, guys, the mass moment of inertia around A, I can find the sum of the mass moment of inertia of all these three beams around A, right? For example, what is the mass moment of inertia of AC around A? It's in fact I of AC around its center of mass G1 plus the mass of AC times D squared, the distance from G1 till A. So I can apply the parallel axis theorem to find the mass moment of inertia for each beam and then sum them up to find the mass moment of inertia around A. Okay, guys? So let's start. What is the mass moment of inertia for the first beam? It's 1/12 times the mass, which is 3. So I'm considering it as a slender rod because I don't know the thickness, and it's obvious, guys, that the thickness is neglected compared to the length. The length is 1.5 squared. So I can apply the mass moment of inertia for a slender rod plus m times, which is 3, times d squared, the distance between this center of mass and A, which is what, 0.75 squared plus 1/12 times 3 times 1.5 squared also, plus the distance from its center of mass, which is here, and A, which is 0.70. The distance between this G and A, no, what is the distance between G2 and A? It's the radical 1.5 squared plus 0.75 squared, and since it's squared, I can directly say 1.5 squared plus 0.75 squared and the last term, of course, this is I. This is I with respect to A, guys, okay? And the last term is 1/12 times 3 times 1.5 times the distance between A and G3, which is also 1.5 squared plus 0.75 squared, which is the same as this one. Alright, so it is the same. And then if you do it, I have the value. It will be equal to 20.25. Now, what is the unit of mass moment of inertia? The mass moment of inertia is always m times the distance squared. So it's kilogram meter squared. All right, guys? So that's it. This is IA. Now, what is the sum of moments around A? As I said, it's only the weight. What is the distance from the weight at the center of mass? And this A, what is this distance? What is this distance, guys? It is 1, because I know that the center of mass is located at 1 in X, which means, guys, 9. This is the mass times the gravity times the distance is equal to 20.25 times alpha. Alright, so I can find alpha. Alpha is equal to 4.4 radians per second squared. Now the last step is to find what? It is to find AX and AY. How to find AX and AY? By applying these two Newton's second law. The first one is equal to 0, since omega is equal to 0. And the second one is equal to m alpha times r. I know alpha, I know r, so I can find them. Okay? So, this is, let's state our free body diagram. So, as I said, this is a x. Assume that this is the positive direction. And this is a y. I know that this is G. Now G is located at 0.75 here and at 1. Which means, guys, if I put the tangential and normal direction, so let's say this is, as I said, the tangential, and this is the normal. Sorry. So this is the normal. And this is the tangential. Then, guys, I know that this normal direction is towards A, all right? Then this angle here, if I want to find the angle between this normal and AX, because in fact I need to do the projection, this tangent of this angle is equal to y bar g over x bar g, all right? So it will be equal to tangent of 0.75 over 1, which is in fact 36. No, it's not sine. It's you can use RG, but you can use also tangent. So it's y bar over x bar. So 36.8. All right. Okay. So which means, guys, that the angle between AX and AN is 36.8, and this is the same as the angle between T and the center of gravity, so they are all the same angle that I'm gonna call phi. Okay, so now guys, you can do the you can do the first two equations. So sum of Fn is equal to 0 because I'm gonna find it at this instant right here. This doesn't mean, guys, that omega is always equal to 0. No, at this instant, at the instant in this figure, guys, at the instant shown, omega 0 is equal to 0 and alpha 0. So this is alpha 0, in fact, is equal to 4.4. So at this instant, since omega is equal to 0, then the sum of F normal is equal to 0, which means if I want to find the weight and do the projection to the normal force, then the weight will be in the negative direction, minus 9 times 9.81 sine phi, which is 36.8, plus AX cosine phi plus AY sine phi is equal to 0. And then if you apply the second equation, which is sum of Ft, now it's not equal to 0, it's equal to m, which is 9 times alpha 4.4 times Rg, which is 1.55. All right? And this means that 9 times 9.81, which is the weight here, times cosine phi in the positive direction, because in fact t is downward and the weight is downward. Okay, plus ax sine phi minus ay cosine phi is equal to this one. This means, guys, you can now have two equations to unknown, so you can find ax. It is almost equal to 29 Newton and ay 49. Alright, guys? So that's it. Of course, guys, you can apply this Ig times alpha, and you have to find Ig in the same manner, guys. Ig is the mass moment of inertia around G, so it's around G1 plus md squared, around G2 plus md squared, and around G3 plus md squared. And then you can have to find the third equation. The third equation will be in terms of ax, ay, and alpha, all right? So that you can have three equations, three unknowns. But it's much easier, guys, to find the mass moment of inertia, or the sum of moments around A, since ax and ay will vanish, so that I can find from this equation directly the angular acceleration, and then you can find all other unknowns. Now Hassan is asking why omega 0 is 0. How did we know it from the figure? Of course, we did not know it from the figure, Hassan. We know it from the given. It is released from rest, right? It's released from rest means omega 0 is equal to 0. But the question is to find the acceleration at this instant, in the position shown. At this instant means at this configuration. Because in fact, if you're going to find it at another instant, let's say at t1, then this will not be horizontal and this will not be vertical, right? So at this instant, omega 0 is equal to 0 and alpha 0 is equal to 4.4. All right, Hassan? Then you can find ax and ay. So that's it, guys. This is for this problem. Do you have any other question? Any other question? Okay. So example 8, I'm gonna skip it, right? But it's the same concept, okay, guys? You're gonna have here two normal forces. One is at B and one is at A. It will be oblique, but it is also in the radius direction. And don't forget that here you have a mu, which means I'm gonna have a friction force that should be perpendicular to the normal, and this means it should be tangent to the circle at this point and tangent to the circle at this point. And you're gonna have to find the initial angular acceleration of the cylinder, so you have to find the same equations and apply them. Doctor, why was the W multiplied by sine alpha? Where? The weight, you mean? Because in fact, I'm doing it in tangential and normal direction. Okay? So I know that this is phi. All right? This is your phi here. So if you have to find the projection of the weight in the tangential direction, then this will be sine phi, not cosine phi. In the tangential direction, it is sine phi. Don't forget that the equation of rotation is sum of Fn and sum of Ft. Because in fact, even if I have a rotation, but this G here is doing a curvilinear motion, which means I have to apply the equations in tangential and normal direction, the equations of second law. Okay? Okay, Karim? So I'm doing them in these two directions.